Welcome back. Last video we covered what idors are and why they're such a persistent problem. Now let's get into the fun or terrifying part, how attackers exploit these vulnerabilities. Understanding the attacker's mindset is crucial. idor exploitation isn't super advanced hacking. It's disturbingly simple, making it dangerous. Here's the typical attack flow. Step 1. Discovery. Attackers identify direct object references in URLs like example.com/invoice/1234, API requests, cookies, or post body parameters. Tools like Burp Suite or browser developer tools make this trivial. Step 2. Pattern recognition. They study the ID structure, sequential numbers, random strings, or UUIDs to enumerate other valid references. Step 3. Manipulation. They change the reference, incrementing numbers or testing variations to see what happens. If unauthorized access occurs, an idor vulnerability is confirmed. Step 4. Exploitation. They scale the attack, accessing thousands or millions of records by iterating through IDs in minutes. That's the scary part. Let's start with URL parameter tampering, a textbook example that still frequently works. On an e-commerce site, a URL like shop.com/order?ID=8472 points directly to an order. An attacker changes the ID to 8473, 8474, etc. If the application doesn't verify ownership, it serves the data. This allows access to others' orders, shipping addresses, items, payment info. This isn't theoretical. Major platforms have had this. Developers sometimes think post-body references are safer than URLs. Nope. Attackers intercept HTTP requests with tools like Burp Suite and modify post parameters just as easily. For example, updating a profile might send post/update_profile user_ID=12345 and email equals new email at example.com. An attacker changes user_ID to 12346, updating someone else's profile, potentially triggering a password reset for account takeover. The key insight: object references in URLs, post bodies, headers, or cookies are exploitable if not properly validated. Some applications store object references in cookies, like user_account=789, thinking they're safe from visibility. But cookies are trivially easy to modify using browser developer tools, extensions, or Burp. If an application trusts a changed cookie value without verification, an attacker accesses someone else's data. Changing role=user to role=admin in a cookie grants administrative access, a complete access control failure. File references are a nasty variant. Applications might name uploaded files sequentially, document_0001.pdf, document_0002.pdf. Without access control, attackers request files directly. Predictable paths like /uploads/user_12345/document.pdf allow access to any user's files by changing the user ID. Combined with path traversal, an attacker might try ///etc/password to access system files. Improper input sanitization can expose configuration files, source code, and database credentials. Modern apps use APIs, often hiding object references in requests. Burp Suite intercepts all HTTP traffic, including API calls. An attacker finds an API endpoint like /API/documents/get, sending a document ID. They automate enumeration through IDs to download everything. This is dangerous as APIs handle sensitive operations like payment processing or admin functions. idor vulnerabilities here have massive impact. Automation is truly scary. An attacker finding an idor with sequential IDs writes a simple Python script to iterate through millions of IDs. They can scrape massive data overnight, exfiltrating entire databases without alarms. No SQL injection, just incrementing numbers and collecting data. Bug bounty reports show idors allowing access to millions of user records due to a single endpoint lacking authorization checks. Let's talk tools. You don't need sophisticated software. Burp Suite is the gold standard for web application testing. The free community edition works for idor testing. OWASP Zap is an equally capable open-source alternative. Browser developer tools, accessed by F12, inspect and modify requests. Simple Python scripts with the requests library automate idor testing in minutes. The incredibly low barrier to entry means more potential attackers and higher risk for vulnerable applications. You might wonder why rate limiting doesn't catch this. idor exploitation often looks like normal traffic. An authenticated user requests resources at a slightly higher volume. Without specific detection for sequential ID enumeration, these attacks go unnoticed. idor exploitation techniques are straightforward, making them accessible to all skill levels. This danger means even unsophisticated actors can cause serious damage. Next video, we're diving into specific idor patterns and where you're most likely to find them in real applications. See you there.